Today I'm going to solve another problem from the Mathematical Olympiad. This problem was given in the Germany Mathematical Olympiad, and I believe that if you can solve this problem, you're smarter than Einstein, because it involves, for solution of that, you really have to come up with lots of logic, and it's not um, uh, you cannot use a classical method to solve it. Now in here, we have 2 to the x equal to x to 32. We are looking for the smallest value of x, and the assumption is x is an integer. X can be 1, 2, 3, 4, 5, and so forth. As you can see in here, I wrote the problem again. 2 to the x equal to x to the power of 32. In here, first thing, by looking at this, we can immediately tell x must be positive. The reason for that is very simple. Suppose x is negative. Suppose x is -4. If x is -4, we know that 2 to the power of -4 is going to be 1 over 2 to the power of 4, and it's going to be much less than 1. But -4 to 32 is going to be a very large number. They can't be equal. So a cannot be negative, because no matter, if we already know that x is integer, but no matter what value it holds, because negative would be in the exponent, is going to be 1 divided by that number, which is less than 1, but for the left side, but the right side is going to be more than 1, and it's impossible that these two terms be equal with each other. So we can definitely say x must be positive. That is the, and I wrote down the reasoning behind it. X must be greater than 1. Now, even though we said it is integer, let me tell you why it also has to be greater than 1. Because x, if it is less than 1, let's say 0.5. See, one of the assumptions was it is integer, so it can't be 0.5, but even if he hadn't told us, we can bring this logic. This is more logical type of problem. So it's not like a classical problem. You can solve it with logic rather than you solve it with some numerical manipulation and stuff like that. In here, x must be greater than 1. Even though if he hadn't told us it is integer, we could justify that must be more than 1, because if it is less than 1, let's say x is 0.5, then 2 to the power of 0.5 or 2 to the power of anything even less than 1, the left side is going to be 2 to the power of anything would be between 0 and, between 1 and 2. And however, if x was, let's say, 0.5, the right side would be 0.5 to 32. So that is going to be a number much less than 1. And it is impossible these two to be equal. So again, logically, even if he hadn't told us x is an integer, we could conclude that it cannot be a number less than 1. Now, again, going back to our problem, we can say that x must be an even number. or x must be in a form of 2k, because remember in here 2 to the power of x, which is an integer, give us a number which is 2k, because I'm raising 2 to the power of an integer number. So the right side must be also an even number, cannot be an odd number. 2 to the power of anything which is integer give us an even number. It can't be an odd number. So that means x must be even number, and it must be in a form of 2k. Okay. Now, looking at this problem in this form, x, if we take the 32nd root of both sides, we will have x equal to 2 to the power of x over 32. Remember, x is an integer. If x is an integer, then we can, and we said x has to be more than 1, so that tells us that x over 32 must be more than 32, because I want to get an integer for x. If I want to get an integer for x, then if x is x over 32, let's say become 3, then 2 to 3 is 8, and if 2 to the I'm sorry, if x, let's say, is equal to 3, if let's say x is equal to 8, which is less than 32, then 2 to the 1/4 is impossible to be equal to 8. So x really, and beside 2 to the 1/4 would not give us integer. So that tells me easily that x must be greater than 32. If x is greater than 32, 2 will be raised to something more than 1. And the chance of the result to being more than 1 is much more than if x is less than 32. If x is less than 32, then like 28 even divided by 32, 2 to the 28 over 32, give us a number less than 2. So that's impossible to be equal to 32. Remember, even x is 28, when you raise 2 to 28 over 32, it is impossible to become 28. So this x must be greater than 32. So to create a number which is greater than 32. If it's less than 32, it cannot give us an integer. And in here, I had explained it in here. So in general, x has to be in a form of 32p. Because if it is in a form of 32p, then it would be 2 to the power of p, where p itself is an integer, and the result would be integer. If it is not in a form of 32p, we won't get an integer by raising 2 to the power of x over 32. So x must be in a form of 32p. If x is a form of 32p, then 32 and 32 cancel out, and that means 32p would be 2 to the power of p. So from here, 32 is 2 to the 5 times p equal to 2 to the p. If we divide both sides by 22 to the 5, we will get p equal to 2 to the p minus 5. And p has to be integer. I told you earlier that p must be integer. because if it is integer, when we substitute in here, 32p give us 2 to the p, and only if p is integer, we will get 2 to the power of an integer, give us an integer. If it's a real number, it's 0.5 or whatever, we won't get integer. So the final answer which we have is p equal to 2 to the power of p minus 1. So as you can see, this problem is not a classical problem. You have to solve this by logic. That's why I said if you can solve this problem, probably you're as smart as Einstein or even smarter than Einstein. So finally, my p must be equal to 2 to the power of p minus 5, where p must be more than 5. P cannot be less than 5, because if p is less than 5, then in the right side, we get a number less than 1. Remember, if it is, let's say, 4, then 2 to the power of 4 minus 5 would be 2 to the power of minus 1, or 1 over 2. 1 over 2 equal to p. P is an integer. P must be integer, but 1 over 2 is not an integer. So that tells me p is greater than 5. And for example, it might be 6, 7, 8, or 9. Furthermore, remember, p is equal to 2 to the power of p minus 5. So that means p must be in a form of, first of all, even number cannot be odd number, like 5, 7 and 9 cannot be answered. Secondly, and that's very important, it should be a power of 2, because p is 2 to the power of something which is integer. The very first number which has that kind of property in here is 8. So in here, my p in this particular problem should be in form of 2 to the a, as I told you, and the only answer is 8. So if we go back to what originally we had, x was 32p, or 8 times 32, and from there it would be 256. So as you can see, sometimes the problem which come in the Olympiad, it seems difficult like this, but you have to use the logic to be able to solve them. If you try to solve them by classical method, it would be very difficult to solve them. But if you use logic, then you can solve them. Thank you very much for watching our video. If you liked my video, don't forget to subscribe to my video and press the bell button and press the like button and share it with your friends. So next time when we put a new video, you'll be first one to watch it. Thanks again, and I hope all of you be successful in the Math Olympiad, no matter which country you are taking the exam from.